Question number 7. Okay. Seventh is y is equal to under root e root x. Okay. So we need to apply the chain rule. So can you tell me, this can also be written as y is equal to e root x to the power half. Okay. So this dy by dx can be find out like this. So Nabil, can you tell me that we will differentiate this with respect to what?
E raised to root x.
Good. Then e raised to root x with respect to what?
E raised to x.
Root x.
Root x.
And root x with respect to x. Okay. So here we will get what? 1 by 2 under root e root x. Here we will get the same function. And here we will get 1 by 2 root x. So this will be equal to e root x by 4 under root e root x into root x. Okay, Nabil?
Yes, sir.
Okay. After this, question number 9.
Yes, sir. 1 minute.
Okay. Okay, so Atif and Uzefa, you have joined. Just give me a minute. We will start our lecture soon. And Atif, you were absent yesterday. So did you check the recorded lectures? Because we have started limits yesterday. Atif, my voice is audible.
Yes, sir. Can you repeat what you said?
Yeah, I was saying, did you check the recorded lectures of yesterday lecture?
No,
You
sir.
are-
I did not receive the lectures.
Okay. Then please contact the consent team for this. Okay.
Then, sir.
Yes, sir.
Okay. Next is question number 9. Okay. 9th is what? Y is equal to cos x by log x. Nabil, what's the doubt in this? Here we will apply the quotient rule. So dy by dx will be equal to what? Log x into derivative of cos x minus cos x into derivative of log x by log x square. So this will give us dy by dx is equal to log x into minus sin x into minus cos x by log x square. And we can take LCM and can write this like this. This is x. So minus sin x into log x into x minus cos x, okay, by log of x whole square. And this can further be written like this: minus x sin x, this is the same thing, and minus cos x by x into log of x whole square. Okay, Nabil? Okay. So let me know once you note it so that we can start the today's topic.
Done, sir.
Okay, great. So before that, I will share your homework status. Okay. Just give me a minute. This is the status. So we have right till now, we have shared 8 assignments with you all. Okay. So Atif, you have not submitted any assignment yet. Did you completed any assignment, Atif?
Yes, sir. The first 4 assignments I have completed. I have submitted in the WhatsApp group.
You have already submitted?
Yes, sir. Only the first 4 assignments.
Okay, that's fine, but not sure why I do not receive it. So will you please just give me a minute? Just 1 minute. Okay, so I'm again sharing my number. Atif, I do not found your assignment on the group. So could you please share the assignment on this number?
Yes, sir. 1 minute.
Okay, okay. You can share after the class. But Atif, you have completed 4 assignments. What about the rest?
The rest I have not completed yet.
Please complete it, okay? Because we have already completed the differentiation, and today we will start continuity. And it's a very, very important topic.
Yes.
Okay. Okay, now Noma is absent. Josefa. Josefa, how many assignments you have completed? Josefa, how many assignments you have completed?
So only 3 till now.
3. Why? We have
Yes.
already completed this topic. Okay, and this is your board exam, all of you. And you will not again get so much time for the same chapter. Okay. Today is 24th July. Almost this month is going to end. And hopefully next month we will complete this part first. So you will not get again so much time for the same chapter. So please, all of you, complete the assignments. There are very, very important questions in the assignment which had come in the previous year. Okay. So Zephyr, you have done only 3 assignments, but I guess you have not shared that on the group. Zephyr. So I have already given my number, Zephyr. So after the class, please share your homework. Okay, because I need today we need to share the status with your parents. So please share the assignments. Next is Nabil. Nabil, how many assignments you have completed now?
Sir, I'm in the 4th one, sir. I got stuck up a bit there. because-
Okay. You're on the 4th one. Then please share the remaining with me on the
Yes,
mail.
sir. One I already sent in a group. Now I share it to you on personal chat.
Okay.
Third one I'll send you after class.
Oh, okay, great.
Thank you, sir.
Okay, thank you. Then next is Nabil Khan is absent. Sav, how many assignments you have completed? I received 2 assignments from your side.
I have completed 5.
5. Okay, Sav, will you please share the assignment on my personal number?
I have shared all 5. Sir.
All 5 with me. Okay, then I will check it and I will update this sheet. Darshan, how many assignments you have completed? Darshan, how many assignments you have completed? Assignment 3. That means from 1, 2, and 3, Darshan. Okay. But Darshan, I do not receive any assignment from your side. So please share it after the class. Okay. We need to share this status with your parents. So please share it. And one more thing, today you have a test of differentiation. Okay, after the class. Okay, Darshan. Okay, so okay, then we will continue our yesterday topic. Yesterday we were doing limits and continuity. So just give me a minute. Okay, so next our topic is continuity, but in continuity, there is a use of limits which you have done last year. So we were doing the revision of this topic. Okay, we yesterday we have done two topics: direct substitution method and factorization method. Okay, Atif, you were absent yesterday, but I hope you remember the topics which you have done in class 11. Okay. So hope you
Yes.
remember that we have a direct substitution. For example, in this case, we will directly put the limits. Okay, so the answer will be 3 into 1 square plus 4 into 1 plus 5. So this will be equal to 3 plus 4, 7, 7, 5, 12. Second our method is factorization method. Here, if you will put the limit directly, and you're getting a 0 by 0 form, then in that case, we need to factorize this one. Okay, so we will write like this: limit x tends to 2, x square minus 5x. So we can write it like this: minus 3x minus 2x plus 6. Okay, by x square minus 2 square. So take out common. Limit x tends to 2. Take out common, x minus 3 minus 2 x minus 3 by x minus 2 into x plus 2. This is equal to limits x tends to 2. So this is x minus 2, x minus 3 by x minus 2 into x plus 2. Okay, this will get cancelled out. So put this limit, you will get then 2 minus 3 by 2 plus 2. This also we have discussed yesterday. Okay. Atif, these two are clear?
Yes.
Okay, great. Now next is rationalization method.
Sir,
Okay.
the third question, how should we do, sir?
This one, third question.
Yes, sir.
Okay, so this is not quadratic. That's why we can't factorize this directly. So in such type of cases, what we will do, we will, in place of x, we will put a value. For example, you can try to put 2 here. So you will get what? 2 cube. Okay, minus 3 into 4 plus 4. So this is 8 plus 4, 12. So this will give you 0. If you are putting in the numerator 2 and you are getting 0, then that means x minus 2 is the factor of this expression. Okay, if you are putting x is equal to 2 in a equation, in a polynomial, and you are getting a 0, then that means x minus 2 is the factor of this. So what you will do, I guess you had done such type of questions in your previous classes. 3x square plus 4. Now you will just divide this. Okay, you will divide this expression with x minus 2. So you will get what? X square, x cube minus 2x square, and so on. Further, you will factorize it like this one. Nabil, can you do this now? Is it fine?
Yes, sir.
Okay. Now, the third one is rationalization. So whenever you will get a question of limits, you will first of all try for the direct substitution, and after that factorization. If both those two types will fail, then you will check with the rationalization method. For example, here, if you will put the limits directly, then you will get a 0 by 0 form. Okay. So we can't proceed with the direct substitution method. That's why we will check with the factorization. This can't be factorized. Now we will check for rationalization. So what you will do, you will multiply and divide this with this expression 2 plus x plus root 2 by under root 2 plus x plus root 2. Okay. Now is equal to, here you will get what? Limit x tends to 0. Multiply this. So a plus b, a minus b. So this will give you root 2 plus x whole square minus root 2 whole square by x into under root 2 plus x plus root 2. This is equal to limit x tends to 0. And here what you will get 2 plus x minus 2 by x under root 2 plus x plus root 2. So this 2 will cancel out. Okay. So finally you will get what? Limit x tends to 0, x by x under root 2 plus x plus root 2. Cancel out this x. So finally you will get what? Limit x tends to 0, 1 by under root 2 plus x plus root 2. Now put this limit here. Okay, so numerator will remain the same 1. This is under root 2 plus 0 plus root 2. So this will give you 1 by 2 root 2. So this is the final answer. Okay, so what you need to do in the rationalization method, just multiply and divide with the same expression where you have a root and change its sign. Okay, there is no need to note down this first. Please try the second question. Please try the second one and change this sign, multiply and divide, and do in the same way as I have done the first question. Please share your answer once it is done. Okay,
Sir, is
good.
it root, sir?
Very good. Saf and Nabil, both of you, your answer are correct. Rest of you, please share your answer or let me know if anyone is facing issue in this question. Atif, Darshan, Muzaffar, is it done? Okay, Muzaffar, good. Atif and Darshan, is it done?
Sir, can you explain?
Yeah. Okay. Okay, Darshan, please check here. So this is limit x tends to 0. Okay. So x by under root a plus x minus under root a minus x. Okay. Into under root a plus x plus under root a minus x by under root a plus x plus under root a minus x. This is equal to limit x tends to 0. Okay, x into under root a plus x plus under root a minus x under root a plus x whole square minus under root a minus x whole square. This is equal to limit x tends to 0. This is x under root a plus x plus under root a minus x by a square means a plus x minus a minus x. Okay, this is equal to limit x tends to 0 x into under root a plus x plus under root a minus x by open this bracket a plus x minus a plus x. A will cancel out. So here you will get limit x tends to 0 x into under root a plus x plus under root a minus x by x. So this x will, oh, sorry, 2x. This x will cancel out. Now put this limit. So what you will get? Here put this limit a plus 0 plus under root a minus 0. So this is equal to twice of under root of it. Is it fine? Darshan and Atif? Okay, great. Atif, is it clear?
Yes, sir.
Okay, then please do the third question in the same way and confirm your answer. Okay. You might have already done this in class 11th. Okay, there's a class 11 topic, not of 12th, because I need this in continuity. That's why we are again doing this. So please complete question number 3 and share your answer.
Sir, is it 2
Yes, Nabil. Nabil, what the answer you are getting?
Sir, is it 1 by A?
1 by A, that's correct. Good.
Thank you, sir.
So I got 1 by
Good, Atif. It is correct. Darshan, Huzaifa, Saf, do you get the answer?
Yes, sir.
Okay, good. Huzaifa and Darshan, is it done? Okay, Huzaifa, do you have any doubt here? Okay, okay. Let me solve it. Darshan, is it done? Okay. Darshan, what the answer you are getting? Darshan, what's the answer? Darshan, what's the answer? Okay, so we will rationalize here only. We need to rationalize this. This is under root of a square plus x square plus under root of a square minus x square by under root of a square plus x square plus under root of a square minus x square. Okay. Now, this is equal to multiply the numerator. So you will get limit x tends to 0. And here you will get a square. That means under root a square plus x square whole square minus under root of a square minus x whole square by x square into under root of a square plus x square plus under root of a square minus x square. Okay. So this is equal to limit x tends to 0. So in the numerator, you will get a square plus x square. Open this bracket. You will get here minus a square minus x square. Okay. By x square. Here you have under root of a square plus x square plus here you have a square minus x square. So this is equal to limit x tends to 0. Open the bracket. So you will get a square plus x square minus a square plus x square by x square into here you have a square plus x square plus here you have under root of a square minus x square. So cancel out this. So you will get here limit x tends to 0. Okay. Here you have x square by x square and in the bracket you have a square plus x square plus under root of a square minus x square. So cancel out these two. So finally you get, I will write here, okay, on the top. So finally you will get this one limit x tends to 0.
And so you get 2x square.
Sorry, we will get a 2x square. Good, thank you. So here you will get a 2 and here put the limit. So you will get under root of a square plus under root of a square. So this will, okay, we have put the limit, so we will not write the limit here. So 2 by, this is a plus a. So this is equal to 2 by 2a. 2 will cancel out and we will get a 1 by a. Okay, so Huzefa, is it clear? Huzefa, is it clear? Okay, so Darshan, you have not shared the answer. Okay, but I hope you are getting this 1 by a. Okay. Now, hopefully, all of you understood this rationalization method. Now we will proceed to next topic. Is it fine? Everyone has done this? Okay, I'm going to change the slide. If anyone has missed anything, please let me know. Next is we need to solve the algebraic limits by using some standard results. Okay. So that result is, first is this one, limit x tends to a, x to the power n minus a to the power n by x minus a is equal to n a n minus 1. Hope all of you now remember this formula which you have done last year. Okay, so for example, if you will take a question, limit x tends to 3, okay, x cube minus 3 cube by x minus 3. So what will be the answer? Compare with this. If you have x tends to a, x to the power n minus a to the power n by x minus a, this is equal to n a n minus 1. So this will be equal to, what is n? N is 3. Here 3. What is a? A is 3. N minus 1 means 3 minus 1. So this will give you what? 3 into 3 square. So this will be equal to 3 into 9, which will give you 27. Okay. There is no need to note down this. Please try this question number first and share your answer. If the calculation is very, very lengthy, then please don't do the complete multiplication. Just tell me the answer. Okay, for the first one, please complete it and let me know.
Sir, is it 5120?
Okay, Nabil, 5120. So, can you tell me in terms of, okay, let me complete this. Okay.
10 into 2 raised to 9, sir.
Okay, great. So this is equal to, we can, all of you please check here. This is limit x tends to 2, x to the power 10, minus this can be written as 2 raised to power 10 by x minus 2. So as per the formula, this will be n means 10, a means 2, n minus 1 means 10 minus 1. So this is equal to 10 into 2 raised to power 9. And once you will multiply this, you will get the correct answer. So is it clear? This is clear to all of you. Atif, Darshan, Zephyr, Saf.
Yes, sir.
Okay, Saf, good. Atif, Darshan, Zephyr, is it clear?
Yes.
Okay. Zephyr and Darshan. Okay, Zephyr. Darshan, is it clear? Darshan, is it clear? Darshan, please message me on the chat box, okay? This is nothing new. This is these all are of 11th topic. Yes. Darshan, I'm saying that is it clear? This formula is clear to you? Okay, great. So I'm just going to change the slide. Okay. Next is trigonometric limits, and we have a standard formula here. So these are the standard formulas. First is this one. You might have done last year also. If the theta is in radian, then limit theta tends to 0 sine theta. This is equal to 0. Okay. If limit theta tends to 0 sine theta, this will be equal to 0. Then you have a limit theta tends to 0 cos theta. This is equal to 1. We have a limit theta tends to 0 sine theta by theta, which will give you 1. Then limit theta tends, this is again theta tends to 0 tan theta by theta, this is also a 1. Okay. So these are the formulas. Please note down this and then raise your hand. Then we will try some questions on the basis of this formula. Everyone, please raise your hands if it is done so that we can start the questions. Nabil, Atif, Darshan, Huzaifa, Saif, is it done? Okay. Rest of you, please raise your hand if it is completed so that we can start the questions. Okay, Atif. Darshan. Okay, Nabil, good. Darshan, Huzaifa, is it done? Okay, Darshan. Huzaifa, is it done? Okay, great. So I hope everyone has done this. Now we will start. Okay, sir. Thank you. The first question. Okay. So please check the limit. Limit is what? Limit is this one. Limit theta, limit sine theta by theta is equal to 1. Okay. Always remember these two angles should be equal. If these two angles are equal, then we will get a 1. And this should be 0. If these two are not equal, for example, if we have this question, limit theta tends to 0, sine 2 theta by theta. Okay. Here theta are different. In the numerator, we have a 2 theta. In the denominator, we have a theta. So what we will do, we have to make this equal. So we will multiply this with 2 and divide with 2. Okay. Never multiply this 2 in the angle. Always multiply this outside the angle. So 2 is a constant. You can write this 2 outside the limit. So you will here get limit theta tends to 0. Okay. And this is what sine 2 theta by 2 theta. This is equal to 2 and this will give you 1. So the final answer is 2. Is it correct? Everyone, this is clear? I hope this is clear to everyone. Now please try this first question. Okay, try this first question and tell me the answer.
Three, sir.
Very good, Nabil. Seth, very good. This is correct. Now, similarly, please try second question and share your answer. And rest of you, please share the first answer or let me know if anyone have a doubt in the first question.
So first one I got 3.
First is 3. Very good, Atif. So Seth, okay, Seth has completed. Huzaifa, Darshan, please tell me the first answer. Good, Darshan. It is correct. Josefa, what is the first answer? Josefa, what is the first answer? Josefa, please let me know if you have a doubt in this.
Sir, it's the second one 5/2.
Second one, 5/2. Yeah, that's correct. Good.
Sir, I got 2.5.
Good. This is good. Good.
So is the
Josefa.
third one A/B?
Third one, A by B. Good. Josefa, very good. Rest of you, please share the second answer. The second, Atif has completed, Nabil has done, Darshan, Josefa, and Saif. Yes, Darshan, this is correct. Good. Josefa and Saif, please share the second answer.
Second one.
Who have a doubt in second? Good, Darshan, it is correct. Who have a doubt in second question?
Me, sir.
Okay, Saif. Please check here. Answer. So we have this limit x tends to 0. This is sine 5x by 2x. Okay, now these two are different. So what we will do, first of all, we will shift this to outside the limits. It is a constant and we don't need this here. So x tends to 0. It is sine 5x by x. Now these two are different. That's why we will multiply and divide with 5. 5, this is a constant. Shift this outside the limit. So 5 by 2 limit x tends to 0 sine 5x by 5x. So this is equal to 5 by 2 into this is 1. Final answer is 5 by 2. Is it clear, sir?
Yes.
Okay, great. Josefa, I hope this is also clear to you. Okay, so I'm going to start the next. Please let me know if anyone missed anything. Okay. Next we have these formulas. Okay. Next is limit x tends to 0, a to the power x minus 1 by x. This is equal to log a. Okay, and the base is e. So that means there is a natural log. If you again, I'm explaining you the first one. If you have a limit x tends to 0, this is a to the power x minus 1 by x. So the formula is log a. Similarly, if here you have a e, then in place of a, you will get a e, and this will give you 1. Next is limit x tends to 0, log 1 plus x by x is equal to 1. Okay, so I will give you one question here. Please note down these formulas, then try this. Limit x tends to 0, 2 raised power x minus 1 by x. Please note down these formulas and tell me the first answer.
So log 2.
Very good, Atif. It is correct. All of you, please note down the formulas and confirm me the answer of the first question.
Sir, log e to the base 2, log 2 to the base e.
Log 2, very good. That is correct. So Atif and Nabil has done. Darshan, Josefa, and Saif, please share the answer of this. Seth, very good. It is correct. Darshan and Josefa. Okay, I got one more answer. Very good, Josefa. It is correct. Darshan is left. Darshan, what's the answer of this? Darshan, what is the answer of this first question? Do you have a doubt in this one? The first question? Darshan, any doubt in the first question? Please compare this with this one. So the final answer you will get is log 2. Okay, and the basis. So I hope this is clear to all of you. So we have two methods and limits. First, the one which we have already discussed. Second is LHL and RHL method. Okay. So I'm going to start the new topic. Please let me know if anyone have a doubt in the previous one. Okay. Okay, now for this one, first of all, we will check this graph. Or okay. Suppose we have this function f(x) is equal to x squared minus 4 by x minus 2. Okay. If we have this function and we are putting the value, for example, here we will write the fx and here the value of x. If suppose we will put a 2, then what we will get is 0 by 0. You can put this value in the numerator and you will get a 0 by 0. So I hope this is clear to all of you. Now, if we go on the right side of this 2, right side means if you will put a value 2.1 here, then what the value you will get is 4.1. If you will put it 2.01, you will get a 4.01. If you will put it 2.001, you will get a 4.001. You will get a 2.33301, then you will get a 4.0001. So what we are doing from the right side, we are approaching this value to 2. This is 2. From the right side, we are approaching this to 2. And we can say that this function, this fx is approaching to 4. Please check here. The more closely you will move to 2, the more closely this function will move to 4. Okay, so we can say when from the right side we will approach this value 2, then the function will approach 4. So for example, in this function, if we will write this as 2, okay, and this is 4. This is 4. So we can say that when we will approach this value from the right side, then when we will approach 2 from the right side, then this function fx will approach 4. Now we will check from this from the left side. If we will put 1.9, you will get a 3.9. If you will put a 1.99, you will get a 3.99. If you will put 1.999, you will get a 3.999. If you will get a 1.4 times 9, you will get a 3.4 times 9. Okay, so if you are approaching this 2 from the left side, then this value fx will approach to 4 to 4. So we can say when this is RHL, okay, from the right side. If we are approaching this value from the left side, then we can see that the function is again approaching the value 4. This is called LHL. What is mean by LHL? LHL means left hand limit. LHL means left hand limit. You have done this in class 11, left hand limit. Okay, and RHL means right hand limit. RHL means right hand limit. Okay, right hand limit. So if we need to find here the value of limit x tends to 2 fx, then what we will do, we will approach this 2 from the left side and from the right side. If this LHL and RHL are equal, if LHL is equal to RHL, then we will say that limit will exist. Limit will exist. Okay. If the LHL is not equal to RHL, LHL and RHL are not equal, then we will say that the limit do not exist. So what is the condition for the limit to exist? LHL should be equal to RHL. If we will check that at this x is equal to 2, this is x, okay, and this is fx. If we will check that what is the value of the function at x is equal to 2, then x is equal to 2, there is no value. So the function is not defined at this value. But if we will check the left hand limit is 4, and if we will find the right hand limit, that is also 4. So what is mean by this limit? I have already explained you yesterday. What is mean by this? This means when you are approaching the value 2, when x is approaching to 2, then fx is approaching to 4. In this case, this doesn't mean that the function have the value 4 at x is equal to 2. No. What does this limit means? When you are approaching this to 2, fx is approaching to 4. Okay, please listen carefully. I'm again saying that when x is approaching to 2, fx is approaching to 4. I'm not saying that the value of the function is 4 at x is equal to 2. Okay, so the meaning of this complete means when x tends to 2, then fx is approaches to what? In this case, fx is approaches to 4. How can we find out this? We will calculate the left hand limit. We will calculate the right hand limit. If left hand and right hand limit are equal, then we will say that the limit will exist. Now the question is in which type of questions we need to find the left hand and right hand limit, and in which type of questions we need to solve the question directly, as we have already discussed the different method. For example, factorization, direct, rationalization, standard limits. These are the direct methods. Second method is left hand and right hand limit. So we need to check in which cases we will use the left hand and right hand limit. So we will use this concept where we have an inequality. In a question, if there's an inequality, okay, there's an inequality sign in your question, then there you will use the left hand and right hand limit concept. If in a question you have a modulus, okay, so in that case we need to define the modulus, and then we need to solve the question by the left hand and right hand limit method. Okay, so please remember this, that in what type of questions we will use the left and right hand limit concept. When there's an inequality in the question, there we will use this LHL and RHL method. If you have a modulus in the question, then we will define that modulus and convert that into inequality. So in modulus also, we will use the left hand and right hand limit concept. Okay, so I hope you understood 40 or 50% this part. Okay, so if anyone wish, you can note down this graph and this table. Okay, and after this, please raise your hand so that we can try some questions on the basis of this concept. Everyone, please raise your hand if you have noted down this so that we can start the questions. Okay. Nabil, Atif, Darshan, Huzaifa, Saif. Okay. Okay, Nabil. Atif, Darshan, Huzaifa, and Saif. Is it done?
Yes, sir.
Okay, Saif. Okay, Atif. Good. And okay, Huzaifa. Darshan, is it done? Shall we start the questions? Darshan, is it done? So I'm going to start the question. Please let me know if anyone missed anything. Okay. The question is check that the limit x tends to 1 fx exist or not. Exist or not. Fx is equal to this what? 1 plus x square. This is 0 is less than equal to x is less than equal to 1. Okay, and this is 2 minus x is greater than 1. Okay, we need to check that this limit exists or not. Okay, all of you please check here. So how we will check this? In which case, who can tell me in which case we will say that the limit exists? When we will say that limit exists?
If LHL and RHL are equal.
Very, very good, Sav. When LHL and RHL are equal, then we will say that the limit exists. So here, first of all, we will calculate LHL. LHL at x is equal to 1. Okay. So in case of LHL, we will write 1 minus x tends to 1 minus. I'm not saying minus 1. Okay, what is mean by 1 minus? If you have a graph like this is 1. Then we are approaching the value from the left side. So 1 minus represent that we are approaching the value from the left side. 1 minus doesn't mean minus 1. Okay, please remember 1 minus doesn't mean minus 1. 1 minus means you are approaching this value 1 from the left side. Okay, now, okay, 1 minus means we are approaching from the left side. So that means the value is slightly less than 1. Okay, the value is slightly less than 1. This doesn't mean that the value can be 0. slightly less than 1, that means the value can be 0.9999 and so on. Okay, so anyone can tell me from these two functions, 1 plus x square and 2 minus x, from these two functions, which function we will use? Okay, first of all, I will write fx. Now, please tell me which function we will use for the LHL.
The first one.
Very, very good, Nabil. The first one. Okay, Darshan, in such a case, please reply me on the chat box. Okay. So, Darshan, is it clear? This LHL at x is equal to 1 and up to this step. Please let me know if you miss anything here. Okay, so all of you, please check here. If you will check this value, so this means what? The value of x is greater than equal to 0, but it is less than equal to 1. So this function 1 plus x square, this we will take 1 when the value is less than equal to 1 and greater than equal to 0. So this is our LHL. LHL means left hand limit. That means we are approaching the value from the left side. So this value is close to 1 from the left side. So we will take this function limit x tends to 1 minus 1 plus x squared. This is the most important step of these type of questions. So everyone, please raise your hand if you understood this one. That why we have taken 1 plus x square and not 2 minus x. Okay, Atif. Okay, Saf. Good. Huzaifa? Huzaifa, is it okay, Nabil? Huzaifa, is it clear? Huzaifa, is it clear? Huzaifa. Okay, so I hope everyone understood this, that why we have selected the first function. Okay, now how we will solve this LHL limit, please check this step. In every question, we will use the same steps. Okay, so the steps are put x is equal to 1 minus h. Okay, we will write x is equal to 1 minus h. Why we are writing 1? First of all, we will check that what is h. When always write like this, when x approaches to 1 minus h approaches to 0. So what does this mean? We are putting the value in place of x 1 minus h. And what is h? H is very, very close to 0. That means this 1 minus h represent a value which is very, very close to 1. Slightly smaller than 1, but very, very close to 1. Okay, so in LHL, we always need to use this 1 minus h. And you always need to write this when x approaches to 1 minus h approaches to 0. So here what you will get, this is 1 plus, in place of x, you will put 1 minus h. Okay, in place of x, we need to write 1 minus h whole square. And here in place of x, we have already written here when x approaches to 1 minus h approaches to 0. Okay, now here directly put the limit. So put this value h. So you will get 1 plus 1 minus 0 whole square. So this will give you 1 plus 1, which will give you 2. Is it clear to all of you? Nabil, Atif, Huzaifa, and Saf.
Yes, sir.
Good, Saf. Nabil and Atif.
Yes, sir.
Good. Atif. Atif, is it clear?
Yes.
Good. Huzaifa, I'm not sure you are still in the class or not.
So should we use only 1 minus h or it will change in
No,
different situations?
In LHL, we will always use minus h, and in this case, we have a limit 1. That's why we have put 1 minus h. If the limit is 2, we will write 2 minus h. If the limit is 3, we will write 3 minus h. But in case of LHL, we will always write minus h.
Okay,
Is
sir.
it okay? Now we found out this, that the LHL is 2. Now we will calculate the RHL. So we will calculate RHL. We will calculate RHL at x is equal to 1. So what we will write for LHL, we have written x 1 minus. So here we will write 1 plus fx. Okay, so who can tell me? Huzaifa. Huzaifa, can you tell me from the first and second function, what function we will use for plus for RHL, which function we will use? Josefa, from the first and second function, what we will use for the RHL? Very good, 2 minus x. So we can see here 1, this is greater than 1. RHL means 1 plus, we are approaching from the right side, from this side. Okay, so we will take a value which is greater than 1. So that is 2 minus x. So we will use 2 minus x here and x tends to 1 plus. Again, put x is equal to, in last case, we have put 1 minus h because that was LHL. Here we will use 1 plus h. And in the bracket, always write when x approaches to 1 plus, h approaches to 0. So what we will get here, limit h tends to 0, 2 minus, in place of x, put this value 1 plus h. This you will get limit h tends to 0. Open this bracket, 2 minus 1 minus h. So here we will get limit h tends to 0. 2 minus 1 means 1 minus h. Put this value of limit h tends to 0, you will get a 1. Okay, so RHL you will get a 1. LHL you get a 2. So we can say that LHL, or we will write the symbol, limit x tends to 1 minus fx is not equal to limit x tends to 1 plus fx. Okay, LHL and RHL are not equal, hence limit x tends to 1 fx does not exist. Okay, so if we are getting a LHL as LHL and RHL unequal, then we will say that the limit does not exist. So I hope now you understood this concept, that in LHL RHL case, you need to find out these two separately. If these two are unequal, then you will say that the limit does not exist. If these two are equal, then we will say that the limit exists. Okay, so please note down this and then raise your hand. It is a quite typical concept. Okay, but you had done this last year. I'm not sure that how many of you remember right now, but this was there in the syllabus last year. Okay, so please note down this, confirm me, then I will change the slide. And I'm not sure that we will be able to start continuity today or not. We have 10 minutes. Okay, not issue. We will complete limits. In the next class, we will do the continuity. So please note down this, raise your hand, then I will change the slide.
Sir, suppose that x tends to 1 minus and x tends to 1 plus are equal. So we should also check f of 1, right?
No. That is for continuity. Okay, right now we are just discussing the limit of a function. So there's no need to find out the f1. Okay, Atif?
Yes.
Okay. When we will do the continuity in that, we need to find out f1 also. Okay, I will explain to you this concept from graph, that what is meant by limit does not exist in this case. Okay.
That's it.
Done? Okay, great. So for example, if you have this function, this one, okay. So let this be LHL, we have find out 2. Okay. And RHL is 1. Okay. So the graph is like this. Okay, let this be 2 and let this be 1. So what happened if we are and this value is 1? So what happened if we are approaching this 1, then this function is approaching to 2. If we are approaching from the right side, then this function is approaching 1. So that's why limits are different. LHL and RHL are different. That's why we will say that limit does not exist. Okay. So I hope you have done this. Please do this part and raise your hand. Then I will give you one more question. Is it done, everyone? Shall we start the next question?
Good, sir.
Okay, Saf. Okay. Saf and Nabil, good. Atif, Huzefa, is it done? Atif and Huzefa, is it done? Okay, Huzefa, I got your message. Atif, shall we start the question? Okay. Next question. Okay, so the next is fx is equal to 2x plus 3. Okay. Darshan, I will explain you the previous question. Just give me a minute. 3x plus 1. Okay, and it is x is less than equal to 0. Here you have x is greater than 0. Find limit x tends to 0 fx. Okay, please try this question, and all of you please note down this question first, because I need to change this slide. Okay, first of all, please note down this question.
Done, sir.
Okay, Nabil. Atif, Huzaifa and Saf, did you note down this? Shall we
1
change
minute.
this? Okay. So please raise your hands once it is done.
Done.
Okay, Atif, good. Okay, Saf, good. Huzaifa, shall I change the slide? Is it done? Okay, great. So please complete it and share your answer. Okay, Darshan, please check here. So Darshan, here we need to check that this limit exists or not. So what is the concept here? We will find first of all LHL and RHL. I already told you, I'm not sure you were there in the class or not. I already told you some minutes back that in which case we will calculate LHL and RHL. First is inequality. If you have a question of inequality, then in such a case, we will find out the LHL and RHL. And second is the modulus type of questions. Second is modulus question. So in these two types of questions, we will use the LHL and RHL and not solve the question directly. Now, for example, here we have this function fx is equal to 1 plus x squared. When we will use this function when x is greater than equal to 0 and less than equal to 1. Second function is 2 minus x. This is when x is greater than 1. Okay, so we have these two functions. Now we will calculate LHL at x is equal to 1. What is mean by LHL here, Darshan? That we are approaching, this is 1. We are approaching 1 from the left side. So that's why we will write 1 minus. 1 minus doesn't mean that we are saying minus 1. 1 minus means we are finding the LHL. Okay, now 1 minus, if we are writing, we are calculating the LHL, then that means we are approaching this value from the left side. If you are approaching the value from the left side, then the value will be slightly less than 1. Okay, from the graph only you can see that if you are going from the left side, you are approaching the value 1 from the left side, then this means the value is slightly less than 1. So Darshan, can you tell me from the first and the second one, which function we will use for the LHL? Darshan, which function we will use for the LHL? First one, very good. Okay, so we will write limit x tends to 1 minus fx is equal to limit x tends to 1 minus, we have put this 1 plus x squared. Now, this is standard method. We will write put x is equal to 1 minus h. Okay, why we are writing 1 minus h? Because the value of x is slightly less than 1. And in the bracket, always write when x tends to 1 minus, h tends to 0. Okay, so what we will do here, in place of x, we will write 1 minus h. In place of this limit, we will put h tends to 0. Now put this limit, so 1 plus 1 minus 0, whole square, 1 plus 1, you will get a 2. Is it fine, Darshan? This is clear? Okay, great. So Darshan, please note down this, confirm me, then I will explain you the RHO. Okay, and anyone has completed the second question?
Yes, sir. Limit does not exist.
Limit does not exist. Okay, let me check. I don't think the answer is correct. Nabil, will you please again check the answer? Anyone else has completed the second one?
So you have to find the limit, right?
Yeah, you have to find the limit. If it does not exist, that means LHL is not equal to RHL, then you can write in the exam also that limit does not exist. If they are saying that find the limit and you are getting a LHL, RHL different, then still you can write, okay, that limit does not exist. But in this case, limit will exist. I have checked the question, limit exists. So Nabil, again check it. Darshan, is it done? Shall I change the slide? Okay, great. Now, Darshan, we will find out then RHL. RHL at x is equal to 1. Then again, the same thing for RHL, we will write 1 plus fx. Okay. And 1 plus means for the RHL, we will use the second function, 2 minus x. So we have put here 2 minus x. And in place of x, we will put 1 plus h. Okay. When x tends to 1 plus, h tends to 0. Limit h tends to 0, 2 minus 1 plus h. Okay, so I hope Darshan, you understood this. Next is limit h tends to 0. Open this bracket, put this limit, you get a 1. So you can see that in the LHL you are getting a 2 and the RHL you are getting a 1. So that's why we will say that the limit does not exist. If LHL and RHL are not equal, then we will say, Darshan, that the limit does not exist. Is it fine, Darshan? Darshan, is it clear?
Sir, could you share the question one more time?
Sorry, Nabil.
Second question, sir. Could you just show it one more time?
Yes, I will. Darshan, please let me know. Do you understood the second part? Is it fine, Nabil?
Sir.
Okay, great. My voice is not clear. Now is it okay, Darshan? Okay, please rejoin. If anyone got the answer, the second one, please share. Okay, sir, very good. Limit exists. What's the answer, sir, then?
3.
3. Very good, sir. This is the correct answer. Very good. Darshan, my voice is audible now. Okay, Darshan, then please note down this. Okay. And let me know if you understood this one, the second one, RHL. Okay. Darshan, did you completed it? Shall I change the slide? Oh, okay, great. So anyone else find out the second answer? Saif has completed it. Anyone else? Atif, Nabil, Josefa, Saf. Okay, Saf, you have already done. Josefa. Okay, no issue. I will solve this question. So all of you, please check here. There is an inequality. That's why we will not do this question directly. We will use the LHL and RHL method. So LHL at x is equal to 0. So what we will get here, limit x tends to 0 minus fx. Who can tell me, Atif, which function we will use? First or second?
So first one 2x plus 3.
Very good. 2x plus 3. Next, we will put x is equal to 0 minus h. And the bracket we will write when x tends to 0 minus h tends to 0. So here we will write limit h tends to 0. 2 in place of x, we will write 0 minus h plus 3. So this is limit h tends to 0. Open this bracket, minus 2h plus 3. Put this value, you will get a 3. Okay, so the LHL, you will get a 3. Okay. Now, similarly, you need to find RHL. Can you do this in the homework or? Okay, not issue. I will do this right now. Okay, after this, you have a test of differentiation. Okay, next we will find the RHL. RHL at x is equal to 0. So we will write limit x tends to 0 plus fx. So for this one, we will use a second function, that is 3x plus 1. Put x is equal to 0 plus h. So this is equal to, and in the bracket, write when x tends to 0 plus h tends to 0. So here you will get limit h tends to 0. And here you will get 3 in place of x, you will get a h plus 1. Okay, 0 plus h, so I've written h on. Now put this limit. So what you will get 3, 0 plus 1. So this is equal to 3. So we can say that limit x tends to 0 minus is equal to limit x tends to 0 plus is equal to 3. Hence, the value of the limit x tends to 0, fx is 3. Okay. So I hope this is clear to everyone. Please note down this. Okay. And then please take out the pages and you have a test right now. And before disconnecting, please share your test paper with me. Okay, everyone have my number. So before disconnecting the call, please share your test paper. Okay. Everyone has done this. Shall I stop sharing?
Yes, sir.
Atif, Darshan, Huzefa, Sef. Is it done? Okay,
Yes, sir.
Sef. Okay. Everyone, please complete it. I'm going to share the test paper with you. Okay, so the test paper is of 15 marks. And please share the PDF copy with me. Okay. This is your test paper, total 4 questions. Total is of 15 marks. This is not a tough one. Please complete. similarly, next week also you have a test, okay, of differentiation only, not limits. So the topics we have covered till now. So is it fine if next week I will give you, I will take the test of complete differentiation?
Yes.
Okay, because yesterday also we have just solved the questions. Okay. Okay, great. So next week you have a test of complete differentiation, but I request to all of you, please complete the assignments. Okay, this is your board exam. This is not class 11th. So please complete it and share with me till next week. No, you have a test today. I'm already sharing the test paper with you. The test paper is visible to all. Nabil, test paper is visible. It is only, who have a problem in get Zephyr. Okay, I will share it again. Zephyr, is it fine now? Zephyr? No? Josefa, then please log out and again log. Yes, yes, please. Okay, so please complete it and be prepared for the next week also. Next week, I will take the complete chapter test, only differentiation part. Josefa, is it fine now? Josefa? Okay, Josefa, great.